Okay, so hopefully you've already looked over these three questions. If you haven't, go ahead and press pause and do these three questions. On the first one, if you know two sides of a right triangle, so the big key there is that it's a right triangle. In order to find the third side, you would need to use the Pythagorean theorem. Which we also know is a squared plus b squared equals c squared. Remember that c is your hypotenuse. Number two, if you know two angles of a triangle and nothing else, how can you find the third angle? Well, we would take 180 minus the sum of those two angles. Let's just call them A and B. So we would add those two angles together and then subtract it from 180. On number three, find both missing angles. So here we have three side lengths. Since it's a right triangle, we know we can use SOHCAHTOA. Sorry about that. Since I know all three sides, let's say that I want to find this bottom right angle first. That makes the 85 my hypotenuse, the 51 the opposite, and the 68 the adjacent. Since I know all three sides, I can choose any of the three trig ratios. Since sine is listed first, I'm just going to choose that. So we're going to say the sine of theta, or you could just say the sine of x, is equal to the opposite over hypotenuse, because that's what OH stands for. So it equals 51 over 85. So remember, in order to find an angle, we always do the inverse. So we're going to do the inverse sine of 51 over 85. So on your calculator, wait for it to open. On your calculator, you are going to type in second sine, 51 divided by 85, close your parenthesis, and we end up with 36.869. So if we round to the nearest hundredth spot, after the 6 is a 9, so that would round that up to 36.87. So theta is 36.87 degrees. And that's this angle here. In order to find the last angle, so this angle, well, I now know two angles. One of them is 90, the other one's 36.87. So to find the last angle, I just want to take 90 minus 36.87. That leaves me with 53.13. So this angle here is 53.13 degrees. And I now have solved that triangle. When we go to solve a right triangle, so this is the first part of learning target 3, we have several options. If I'm missing an angle, but I know two of them, I can find the third angle. So this finds the third angle. We can use the Pythagorean theorem. If I have two sides, that'll let me find the third side. Remember, these first two are basic things. These are things that we learned. Triangle sum theorem we learned way back in ES2. Pythagorean theorem we learned in this essential standard, but it was back of learning target 1 idea. But we have to use those two things here in this lesson today. We also have basic trig, so just the things that we have done back last week. So to find a missing side, we know a side and an angle, so we set up SOHCAHTOA. Remember, if x is up high, we multiply. If x is on bottom, we swap them. And then the last one is inverse trig. So this is what we did last class period, where if we're missing an angle, we make sure to use the inverse sine or inverse cosine or inverse tangent to solve for the angle, just like what we did in our last problem on the warm-up. So we're going to solve this problem here in two different ways. I'm going to start by doing the Pythagorean theorem first. So we would say, if we put an x here on ST, we would say x squared plus 5 squared equals 5.7 squared. Remembering that the 5.7 is your hypotenuse because it doesn't touch the right angle. We plug these into our calculator. 5 squared is 25. 5.7 squared, well, I'm going to grab a calculator for that. 5.7 squared is 32.49. So we put in 32.49. I need to solve that, so I'm going to subtract 25 from both sides. So that gives me x squared is equal to 7.49. Remember, to get rid of a squared, we take the square root. So x is approximately the square root of 7.49. So we press second x squared to bring up the square root. 7.49. Press enter. We get this answer. Now remember, normally with a radical or with a square root, we would do a factor tree. But since it's a decimal, we don't need to do that. So 2.74 would be our answer. Because it said lengths to the nearest hundred. So this is 2.74. I now need to find an angle. It doesn't matter which angle I find first. Let's say that I'm going to find angle R. So we label this would be my hypotenuse, this would be my opposite, and this would be my adjacent. Now when I look at these three measurements, I know that the 5 and the 5.7 are exact answers. And I know the 2.74 is a rounded answer because I found it just over here on the bottom left. So if I'm going to use two numbers, I want to use the 5 and the 5.7, which is adjacent and hypotenuse. Adjacent and hypotenuse gives me the cosine. So we would say the cosine of theta, or I could say the cosine of r, is equal to 5 over 5.7. Now remember here we're solving for an angle. Anytime we're solving for an angle, I have to use the inverse. So theta is equal to the inverse cosine of 5 over 5.7. So I plug into my graphing calculator. I press second cosine to do the inverse because I'm finding an angle. And take 5 divided by 5.7. Close your parenthesis, you get 28.69. The directions here say to the nearest degree, so to the nearest degree, this 6 would round it up to a 29 degrees. So we'd say theta is about 29 degrees. And so I can label that here in the triangle, 29 degrees. Now we've got one thing left to solve, that's here at angle T. So we would just take 90 minus 29, because we know the angles of a triangle have to add up to be 180. So 90 minus 29 is 61 degrees. So we put 61 degrees here at angle T. We have now solved that entire triangle. Like I said, that's just one way to do it. We're going to discuss two ways. Here is the second way. I could have done the trig first. So this is the same steps that we just showed on the last one. So they got angle R to be 29 degrees. So we can put 29 degrees in there. We can then take 90 minus 29, gives us 61 degrees. So we've solved this a little bit differently. I found the angles first, and now I still need to find ST. I can do that a couple ways. I could do it with Pythagorean theorem, or I could do it with trig. So I could say the sine of 29 degrees is equal to x over 5.7, because that's my opposite over my hypotenuse. Opposite and hypotenuse give me sine. This, however, is not going to be as exact, because the 29 is a rounded answer. While it would still get me an answer choice that I could probably find a multiple choice answers, it's not the best answer. So I would not suggest doing this, but it is something that would work. The best way is to then go back and do Pythagorean theorem like we did before. 5 squared plus x squared equals 5.7 squared. And now we work the same way, and I end up with the same answer that I had on the last one, which I'm trying to remember was 2.74. So x is about 2.74. All right, last example here, find the unknown measures. So find the unknown measures. This is where this is different than learning target 2. I'm not telling you what one thing I need to find. I need to find all of the missing things. The order here most of the time does not matter. When I look at this problem, I see that angle D is the only angle I'm missing. So that would be the first thing I would find. I would take 90 minus 58. 90 minus 58 is 32 degrees. So I'd label 32 degrees up here. And I would also note in my mind, that's an exact answer. That's not rounded. That's an exact answer because angle F was exactly 58 and angle E was exactly 90. I'm going to go ahead and use my theta down here at angle F, though, and label this as my hypotenuse, this is my opposite, and this is my adjacent. It does not matter which order I find here. I'm going to go ahead and put an X on my hypotenuse. It doesn't matter. I could have put the X on EF. So when I go to solve here, I have the opposite, and I want to find the hypotenuse. The one that uses opposite and hypotenuse is sine. So we would say the sine of 58 degrees, because that's where I put my theta, is equal to 14 over x, because we had to put opposite over hypotenuse. Now what we remember from the Getting Treaty With It song, if x is on bottom, you swap them. So we would say x is equal to 14 divided by the sine of 58 degrees. Now we grab our calculator and we go ahead and plug that in. So we would take 14 divided by, now remember I'm not finding an angle here, so I don't do the inverse, I just do the regular sine of 58. Close your parentheses, we end up with 16.508. This is the side length, so we need to round to the nearest hundredth. So the 0 after that is the 8, which would round that up to 16.51. So we'd have 16.51. And I can go ahead and label that here on this picture, 16.51. Now let's work on our last bit of information. So I need to find the adjacent. I'm just going to put a different variable. I'll put a y there. So now I still know the opposite. I'm going to delete those off of there. I still know the opposite, but now I want to find the adjacent. Opposite and adjacent is tangent. So we would say the tangent of 58 degrees, because that's where I still put my theta, is equal to SOHCAHTOA. TOA is opposite over adjacent, so we put 14 over y. Now just like the sine one, my variable is on bottom. If the variable's on bottom, we swap them. So y is equal to 14 divided by the tangent of 58. So we grab our calculator again, and I take 14 divided by the tangent. Once again, we don't use the inverse because I know the angle. Tangent of 58. We press enter, we get 18.748. So the 8 would round that 4 up to a 5, so 8.75. So that is the length of this. Now a good double check when you're done solving a triangle, make sure your hypotenuse is still your biggest side. So 8, 7, 5, 14, 16.51. The hypotenuse is still my biggest side. So I know that I did that, or there's a good chance I did that problem correctly. If you still want to double check a little bit more, you can plug into your Pythagorean theorem. It won't work out perfectly, but it should come very close in decimal terms. So that's a great double check when you're done with the problem. Now you may turn this in to your teacher, show them that it's done, and then grab your assignment. Thank you.